Okay, so now we're ready to kind of formally define power series. So the series, the sum, as k goes from 0 to infinity, of ck x minus a to the k, where both a and all of our coefficients ck are real numbers, right? This is called the general power series. This is called the general power series. Okay. A, the number A, is called the center of the series. All right, that's the point that the series revolves around. The set of values for which the series converges so in other words, set of x values for which the series actually will be a series that converges. So the set of values for which the series converges is called the interval of convergence. Right? Set of values for which it converges is called the interval of convergence. The interval of convergence. Okay. Okay. R is referred to, capital R is referred to as the radius of convergence. All right, and that is the distance from the center that it converges for. How far can we get away from the center and have it still converge? Distance from the center that it converges for. And that's called the radius of convergence. That's called the radius of convergence. So we'll be talking both about the interval of convergence. That's just going to be an interval of radius r about the center A. So we are going from A plus r to A minus r. Okay. When we're dealing with power series and asking about this question of convergence, we will often use the ratio or root test to find the interval of convergence. And that'll actually be the interval of absolute convergence. Absolute convergence that we'll be looking at there. Okay. When we look at the issue of convergence with power series, there are three possibilities. There are three possibilities. Three different scenarios. For convergence of a power series. And they go from the worst to the best scenario. Worst case scenario is the radius of convergence is 0. That means that your series only converges at the center. Only converges at the center, which makes it a very useless function. You can't do anything with it. So you need to find one place, and that is at the center. Scenario number 2 is that the absolute value of R is less than some number. The absolute value of R, right, is less than some number. That means that we have limited convergence. Right? It converges sometimes and it diverges other times. When we're dealing with this scenario of limited convergence, we have to check the endpoints separately, right? Because this is only going to tell us everything inside of that. But what if we're exactly a distance m above or below the center? Those have to actually be checked separately. So endpoints are checked separately. And then the final possibility is that the radius of convergence is infinite. And if that's the case, then your function, your infinite polynomial, actually converges for all real numbers. Will actually converge for all real numbers. And so what we're going to be doing in the upcoming videos is actually looking at some power series, and we'll look to see what kind of convergence that it'll be doing. And you'll find again that we are very often using those ratio and root tests. And the reason we use those is because, well, how in the world are we going to do an integral test, right, on an infinite polynomial? Right? That's not going to work, right? And what are we going to compare it to? So the comparison test kind of falls flat as well, right? What are we going to compare it to, right? And so those are the two main tests that we have at our disposal that we can use to involve some infinite polynomial. So we're going to be picking up and looking at some of these ideas in our upcoming videos.